Antiderivatives are really important. So if this is your derivative, I would suggest you take time to rewrite it. So this is the same thing as saying 3 over 2 times 1 over x. And then this is like saying 2 over 3 x to the negative 2 minus 3 over 2x. Okay, I left this 1 over x like this because if I have f of x is 1 over x, the antiderivative, make room here, is ln of the absolute value of x. So don't put the x in the negative 1 power, just recognize it. Okay, so then let's take the antiderivative. So f of x will carry the 3 halves outside. You have to separate that number, and then you get ln of the absolute value of x. That's really important. Then I carry along the negative 2/3. And if I take the antiderivative of this gives me x to the negative 1 over negative 1. And then taking the antiderivative here, I get x squared over 2. And so then canceling, and then most general antiderivative means plus c. So let's fix this, ln of absolute value of x. So minus minus makes positive 2/3, and I'm just going to put it 1 over x, and then minus 3/4 x squared plus c. So that is your antiderivative. Let's do this next one. I'm going to erase this so we can have room. Most general antiderivative. So take the time to rewrite it. It's so important. So if I take this, I see that there's subtraction in the numerator of that fraction. So that makes it x squared over x minus 2 over x. And then I've got this minus 4 plus 3. And then anytime I see negative exponents, I write them in the denominator. That's not a thing there. Okay, so let's continue on with simplification, right? So I'm just going to take liberties here. So x squared over x, that just turns into x, right? Okay, so I get x right there. Now I'm ready to take the antiderivative. So capital F of x, antiderivative of x is x squared over 2. This, you know, is negative 2 times the antiderivative of 1 over x, which is absolute ln of absolute value of x. Antiderivative of 4 is 4x. And then I carry along the 3, and I recognize this as arctangent of x plus a c. So that's the most general antiderivative means you always have to put the plus c down. All right, so these are kind of hard, so I want to keep practicing these. So I'm going to suggest we start with those points. So 0, 1, 2, and 3. So it doesn't look like I have any negative numbers. So f of 0 is 0. Got that one. F of 1 is 2. Got that one. F of 2 is 0. And then f of 3 is negative 2. Got it. Okay, so got the points down. Next, you want to worry about where it's going up and down. And I'll do the slopes later. So that would be my first. This would be my second attack. So the derivative positive, that means it's increasing. So increasing from negative infinity to 1, up. And then decreasing from 1 to 2, and then 2 to 3. I'm sorry, 1 to 2. Oh, and then 1 to 2. And then after 2, it's decreasing. Oh, hold on. Did I miss something? Negative infinity to 1. Decreasing 1 to 1. Oh, yeah, all the way to 2. Oh, sorry about that. I missed that. 1 to 2. And then 2 to 3. Okay, so getting the ups and downs is a big deal. So now let's go back and do this line here. So when x is 0, the slope is 3. So that means the slope of the tangent line has to look like 3. Hey, I think that slope could be 3, right? Okay. What does this say? When x is 1, the slope is 0. Oh, yeah, that could be the top of a parabola, couldn't it? When x is 2, the derivative doesn't exist. Okay, so this is always saying the function's continuous. Always, you can't make a break or anything. And so if the derivative doesn't exist, that means it's going to be, let's write this here. This one will have to be a cusp or a corner or a vertical tangent. By looking, since it's going down and down, I'm thinking vertical tangent. So I'm just going to write a straight up and down line like that. And then at f of 3, it's negative 3. Oh, look at that. That kind of looks like, let me get a different color here. That looks like a negative 3 slope, right? Negative 3 slope at that line right there. Okay, so I'm starting to get an idea of what's going on. So the very last thing we do is this. So let me erase a little bit so I can see. Okay, so this is like the end sketching to like enhance the graph. Second derivative negative means it's concave down. So it's always cupped down before 2. Cup down, and then cup down. So then I would get rid of that, right? It's because it's cupped down, and then back, cup down, okay? And then after that, it says that it's cupped up for all x's bigger than 2. Okay, so cupped up, and then cupped up, so that we could have a slope 0 there, right? Or sorry, slope negative 3 there, and it's still cupped up, going down, cupped up. And at that point there, the slope looks like negative 3.